Okay, Bismillahirrahmanirrahim. So, going to start it again. The first application of integration. You must remember that the first application of differentiation was that the dy by dx, that was the gradient of the curve. And using that dy by dx, we were able to write the equation of the tangent, equation of the normal, we were able to determine the coordinates of the stationary points, and we were even able to determine if a function was an increasing or a decreasing function. And at the top of it, you could find those values for which the function was increasing or decreasing. Okay? So similarly, now we have the very first application of integration. It is to get back the equation of the curve that you had before that differentiation took place. Okay, so let's learn that. So now look at this question number one here. It says you have dy by dx that is equal to 3x square plus 1. Guys, you see you're given a point here, and you will find out that why this point has been given to you. It says find the equation of the curve. Now please underline this, because this does happen then in your examination, that you people are required to write the equation of the curve. But the moment you look at this dy by dx, your mouths start watering and you say, oh yes, I know how to write the equation of the tangent. So, the moment you look at this dy by dx, you start dreaming about the equation of the tangent or the equation of the normal. You just forget that the examiner is asking you to write the equation of the curve. So please read your statement very carefully. Okay, so we have to write down the equation of the curve. We're given the dy by dx and we're given a point on the curve. One thing that is understood, that is, you people are good at integration, and now you are going to handle the applications part. Okay, so we're going to get the equation of the curve. Finding this equation of the curve is also going to enable you to learn how to solve a differential equations. You will learn this topic at the very end of your P3, solving the differential equations. You will have very complicated ones there. So this is the simplest differential equation here, because it has a dy by dx in it. Okay, the first step to solve this will always be that you will have dy on one side and you will have the dx on the other side. And you have already this 3x square plus 1, and here it is dx. So the side which has the dx will have all the terms in x. The side which has dy will have all the terms in y. By the way, there is no term in y, so we're just going to integrate it. Okay, so when you integrate this, the integral of dy would become y. And this is going to be 3x cubed over 3 plus x and plus c. Okay. Now we'll see that why this was so important to write this plus c. Now you have y equal to x cubed plus x plus c. Guys, you have been given a point on the curve. So you will substitute this point into this equation here, and you will be able to get your c. Okay. So I'll be putting y as 4 and x as 1. This is 1 cube plus 1 plus c. So we have c equal to 2. Therefore, the equation of the curve is going to be y equals x cube plus x plus 2. So you see, that is why you were writing that plus c. So this is, we just write this plus c because we imagine that if there was any constant and it got eliminated while being differentiated, so this is its, like, spirit here. So you get it back through integration. Okay, so that is why, please, if you don't write this plus c, you will never be able to get the correct equation of the curve. Okay, now the rest is the different levels of this integration here. You must be able to integrate all these different expressions. I'll be doing just one more. Let me do that f part, and then you will be practicing it yourself. Okay. Okay. 1f. Let's do 1f now. Okay. So 1f. So in this 1f, we have dy by dx, that is 1 minus under root x whole square over under root x, and we're given the point P, which is there on the curve. Okay, before I go on to integrate it, okay, let me just write this step here. This is under root 1 minus, sorry, this is not under root. Let me clear okay, so this was 1 minus under root x whole square over under root x, and then there is the dx, and you put those integration marks. But let's play with this. Let's simplify this. Let's write this in a form that we can integrate. So this is a square minus 2ab plus b squared. So that is the square of this 1 minus under root x whole square expanded, okay? And I'll be writing under root x under all of them, okay? So you can simplify that on a side so that you can save your space and you can escape yourself from writing all these terms again and again. So this would be, now I can write it as integral of x raised to power minus half minus 2 and plus x raised to power half. So again, you need to be very good at algebraic simplification, algebraic manipulation. Now this is going to be y, and this is now minus half. You can do all this work on the side. Minus half plus 1 is half, okay? So this is x is for half, and there has to be over half, so I'll be writing it as 2. Integral of minus 2 is minus 2x. Now half plus 1, you should be knowing this mentally. Half plus 1 is 3 over 2. So this is plus x raised to power 3 over 2. And you will write that 2 over 3 here. And never ever forget to write that plus c here. Okay? So this is your integral ready. We are ready to determine this value of c from here. Okay? So let's do that. So the value of c is going to be, we'll be using this point here. So your y is 5. So this is 2, 9 raised to power half minus 2 into 9 plus 2 over 3 into 9 raised to power 3 over 2. If you people are not good at indices, you can use your calculators here, okay? So this is 5 equals 2 into 3, that is 6 minus 18. Now this is 3 square basically, and you're left with 3 cube, 27. This is going to be 18 plus c. Please check this working. I might be making some mistake here. So this is c, your c is minus 1. So if I have calculated this c correctly, then my equation of the curve is 2 under root x minus 2x plus 2 over 3 x raised to power 3 over 2 minus 1. That is the equation of the curve. Acha guys, let's try question number 4 of this exercise. This is a bit different question. Okay. Let me make some space here for this the working. Acha, it says we have dy by dx that is given as kx square minus 6 over x cube, where k is a constant, given that the curve passes through the point P. Okay, fine. We need at least one point here. And that the gradient of the curve at P is 9. So this means he's telling us that when this curve passes through the point P, the gradient of the curve is 9. So that means is indirectly giving you the value of dy by dx is 9 at x equal to 1. So you can determine the value of k even before you start integrating it. You can put your dy by dx as 9, okay? But I hope all of you are listening to me, okay? This is k into 1 minus 6 over 1. So this is 9 equal to k minus 6. So your k is equal to 15. Okay? So this means now we have got the value of k. So this now becomes dy by dx, that is 15x square minus 6 over x cube. And now this becomes a routine question for you. You can write it as dy, that is going to be 15x squared minus 6x raised to the power minus 3 dx. Okay, so you have y equal to 15x cubed over 3 minus 6x raised to the power minus 2 over minus 2 and then plus c. Just cancel by this. 2 3s are, so a bit cleansing here. This is cancelled as well. So you have 5x cubed plus 3 over x squared, and then you have plus c. Okay. So now we put this point on the whole into this so that we can get to that value of c. So your y is 6 and your x is 1. This is 5 plus 3 plus c. So c is going to be minus 2. Finally, your equation of the curve is, the equation of the curve is going to be y equals 5x cubed plus 3 over x squared minus 2. That is your equation of the curve. Acha bacho, question number 7. It says a function y is equal to f of x has gradient f dash of x. So the only difference in this question is that before this you were given dy by dx, and now you're given f dash of x, and that is 8 minus 2x. So remember, now you can, if you integrate this, so you will have to write dx with this. कई बच्चे just write it like this. So बेटा ये बिल्कुल ऐसे ही है. If you are writing cos बस आगे कुछ भी नहीं लिखा हुआ, or you're writing sine, or you're writing tan. So there has to be like, what are you integrating this with respect to what? Okay. So this dx has to be there whenever you are using this symbol of integration, blah 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 blah. There has to be like dv, dt, dy, whatever. You have to mention this thing. Okay. So this is because you dealing with this the first time in this exercise. So you have to write integral of f dash of x with respect to x. It is read as integral of f dash of x with respect to x. And you will integrate this side as well. And please, you can lose marks if you don't follow these instructions. You will see yourself, go back to your working, you will have written this plenty of times, just like, x square plus. So it has to be, whatever your expression is, it has to be here, dx, dy, whatever. This tells you that what is your main variable, okay, through which you're going to differentiate, integrate this. Okay, so this becomes f of x. As you know, when you differentiate f of x, it becomes f dash of x. So when you integrate f dash of x, you will get your f of x back. Okay. This is f of x. Integral of 8 is going to be 8x, and you have minus 2x square over 2 plus c. So this f of x is 8x minus x square plus c. It next says the maximum value of the function is 20. The maximum value of the function is 20. That means that your f dash of x is equal to 20. Hannah? Because just let me clear this first of all, and then I get back to this. Okay. Acha. Um, Oh, I was saying something wrong here. Now, this 20 is actually this maximum or minimum value. This is always the value of y. So, in this case, this will be the value of this f of x. So, it says f of x is equal to 20. And you know that when you have the turning points, there your f dash of x would be 0. And f dash of x would be 0. Only then you get that x coordinate. So let's find that x coordinate where you have that turning point. So let me put that 8 minus 2x equal to 0. This gives me x equal to 4. So this means I can put x4 here. So indirectly we have been given that f of 4 that is equal to 20. So you had to find this, you had to get to this. So this was not an easy question. Okay. So now let's use this information to get to this C here. So f of 4. So you put 4 here. This is going to be 8 into 4 minus 4 square plus C. This is your f of 4 and that is equal to 20. So this is 20 equal to 32 minus 16 plus C. So you have 16. So this is C is going to be equal to 4. Therefore, your equation is f of x that is equal to 8x minus x squared plus 4. Okay. Then it says sketch the graph of f of x. This takes you back to your topic of quadratics. You must be able to determine that what is the turning point, what are the x-intercepts. Only then you can sketch that this easily. Okay. So let's do that, completing the square on it. I'll be taking minus common from these terms in x square minus 8x, and you have plus 4. So this is plus 4 square minus 4 square. So you have minus x minus 4 whole square. 16 plus 4 is going to be 20. So it is going to be a curve like this. Okay. And this point is going to be 4 comma 20. If you put that equal to 0, you can get to know that what are the um, x-intercepts. Okay, if you put x0, so you have 0 comma 4 here, somewhere here. This point is 0 comma 4. And for the x-intercepts, we have this minus x square plus 8x plus 4 equal to 0. X square minus 8x minus 4 equal to 0. So uh, I really appreciate this. Like, I have really wasted all my time here because I really overread that bit. Thank you very much for that suggestion here. Yes, we were given that turning point. You see, I'm getting the same turning point. And who was this, by the way?
Susanna Bakar.
Zainab beta, you are so cool, mashallah. You have seen, but you see, you found it out after I had, like, calculated this stationary point here. So you could have told us before this. Anyhow, I appreciate that. Again, you see, I was going to solve this through the quadratic formula. Since we have got the square completed, so let's use that. So this x minus 4 is going to be plus minus the square root of 20. So x is going to be 4 plus minus square root of 20. So can someone quickly tell me what is 4 minus this and what is 4 plus this? Yes. Hmm? Is here anyone to tell us what are these two values? No one has a calculator? Hmm? Tell me what is 4 minus under root 20?
So minus 0.47.
Okay, minus 0.4. It should be three significant figures. Anyhow, and what is 4 plus this? So this will be,
8.4.
huh?
8.47.
8 point whatever, I can hear you. Okay, 8 point what? 47. Okay, this is 8.4. So this is the sketch of this curve here. You must be able to sketch these quadratic curves. You see, you need to have the turning point, you need to have the y-intercept, and you need to have the x-intercept so that you can sketch this accurately. Okay? So at this point, we end this session where we have learned how to find the equation of the curve when we are given the derivative. Okay, we're using the integration to get back that equation of the curve. Thank you very much.
सर
Yes, beta.
सर जब आपने क्वेश्चन में 4 ट्रायल था तो जो आपने dy by dx को ग्रेडिएट किया था तो उसको इंटीग्रेट के बाद किया था या उससे पहले किया था?
Okay, let me just hold on.